Okay, so we're up. So I guess this is after the second hurricane, so we're hopefully back to normal or into good weather in October. So we're working in chapter 6. Oh, just before we get there, I got the exams. I did get them graded, I think it was within a week of the exam. Passing them back out in class today. And if we take a quick look at it, I went ahead and posted it online. Okay, let's see if I can zoom in a little here. So just to go through it really quick, in a way it wasn't, I didn't think it was as complicated as some of the prior exams. It kind of was all based on a point transformation problem. And so what we've got here is this coordinate system 1. We don't know where its origin is relative to the fix, but we know it's some distance d along that direction that's 30 degrees from the x-axis as measured about the z. And so if I want to get that transformation matrix, basically I want to get this transformation matrix 1 to fix. So I do know the direction of the x and the y of the z of the first coordinate system in the fix just from looking at it, right? The z is 0, 0, 1, and the x is cosine 30, sine 30, 0, and the other is, what, negative sine 30, cosine 30, 0. And as far as the origin of the first coordinate system, all I know it's some distance d in this direction, this cosine 30, sine 30. So when I put the transformation matrix, I do have that one unknown d in there. And then all I did is I said, well, I know point A in the fixed is given, and I know that it was told that in the first coordinate system, point A was in the yz plane. So I know its coordinate system is 0, something, something. The z is going to be 3. So here I said I knew the point A in the first, based on what the problem statement had to be that. And then when I went ahead and put it into the transformation equation, I basically got 2 equations from the top 2 lines, 2 equations and 2 unknowns. In the y, A1, that was this middle coordinate of the point A in the first, and the d value, and then boom, that's what came out. So again, the d value of that and a point of that. So it wasn't, I don't say tricky or maybe as intense, I didn't think, as the other ones, as some of the prior exams. Okay, so put that behind us, and now we're up to, what are we working on now? We do have a homework problem. Let's see when that homework problem was due. Let's see, 18 October, so it looks like Friday. Problem 6.2, 6.3. So one of the problems is basically this problem where I give you all the alphas and I give you one of the thetas, and you have to go ahead and find the 2 solutions, the A and the B case for the remaining thetas. Now when we did this problem, oh boy, it's been probably a week ago, we decided to go for theta 1 first, and when we went into our toolbox, we said, well, it's okay to have all the alphas, it's okay to have theta 4, it's okay to have theta 1. Another way to say it is I want to go in the toolbox, find an equation that doesn't have theta 2 or theta 3. And here's the equation we came out with, because we knew it had theta 4, which is okay. We know it has 1, which is what we're looking for. And when we expanded this definition and then put in all our constants, it went into this format of a cosine plus b sine plus d equals 0. And again, a, b, and d are going to evaluate the numbers. And so how do we find the values of theta to satisfy that? And it turned out there were 2 values, and we showed 2 techniques. One was the tan-half angle technique, and the other we called it the trig solution. And the trig solution is actually, I think, better because it doesn't blow up as much or compared to the tan-half angle solution. But that problem then is the other homework problem. So the first homework problem was given a 4-bar and one of the thetas, solved for the remaining. Second problem was given a, b, d, write a function that does that. And if you do want to see some other cases that are run, if we go to this Qt apps, here's the solve trig procedure, and I went ahead and downloaded it. It's a zip file, and then if we go into that zip file and run it, okay, so I put it over here, I unzipped it and put it here, and we have to look for the executable, and there it is. And this is what it does. You put in values for A, B, and D, and hit solve for theta. So suppose I put in 2.54, oh, I don't know, negative 1.21, and I don't know, 1.1, and say solve. So it shows the two solutions in radians and degrees, and the residuals over here, that's where I took those angles and I plugged them back in. I evaluated the sines and cosines of the angles, and I plugged them back in to see if it did go to 0. And I got, one of them is 10 to the minus 16, and the other one, even the computer rounded it to 0. So it looks like it is doing the solution okay. It could blow up if, remember how the big check is if negative d divided by square root of a squared plus b squared is not between negative 1 and 1. You can't arc cosine that. So if I put a big value of d, like 11.2, I think mine is going to come up and say, oh, yeah, there's no real solution. They would have been like complex angles, which we're not dealing with. Okay, so that gets us up through the homework. So I think you got what you need to do that one. And what we're working on today is the spherical pentagon. So again, with one link fixed to ground, we had 5 moving links. So we looked at the mobility of this, and it was a 2-degree of freedom device. And what we did at the end of the video from last Friday was we generated our toolbox, which is not a lot of fun, but we took Z5 in the 5th and brought it back to the 1st, and we had X432, Y432, Z432 from a long time ago. And then we said, because we're in the pentagon, we can go directly from the 5th to the 1st coordinate system. Remember, 1 is aligned with 5. We rotated alpha 5, 1 about the x, and then theta 1 about the new z, and that was the relationship. And we worked all that out and equated them, and we generated up a pretty good toolbox. And let's take a look at the toolbox. This is where we ended up last class. We had all of these fundamental formula. The one that was, looking for how to zoom in here a little. The one that was, taking Z5 in the 5th and bringing it to the 1st was this one right here. Whoops. You are a pen. There we go. And then if we did all the other possible, like take, Z4th in the 4th and bring it to the 3rd, go in the short way and the long way, you'd get another one of these sets. And again, we can do it, get 10 times. Got them all. Thanks. Here, I'll throw them back in the bag. Okay, so we got this giant toolbox. Then we went ahead and said, well, what if I take S5 in the 5th, and instead of just going to the 1st coordinate system, what if I go 2 steps? I go to the 2nd, and I go the short, call it the short way and the long way. If we did all that work, although I got a little bit lazy, you would generate all these subsidiary formula. And boy, there was a bunch of them. And then we could generate the polar. I think I'm still scrolling down. What's the matter here? Oh, my mouse is doing what it feels like. There it is. We got all these polar equations, which we haven't had to use at all yet for the problems that we're doing, but they're all valid equations. And there was fundamental and subsidiary. So, okay, so we got this giant toolbox. So let's go ahead and start solving problems today, because that's our goal. So the problem that we're going to start off with is this one. So again, I'm given all 5 alphas, and I'm given, have to be 2 of the thetas, so I just picked 2. I took 5 and 3. All right. So alpha 1, 2 through alpha 5, 1. And it was a 2-degree of freedom device, so we went for those. So let's go ahead and find theta 1, theta 2, and theta 4. And here's my planar representation. Right, and these are all modeled as revolutes. And I'm going to go ahead and circle the ones that were given, 5 and 3. So when you go to tackle this problem, then it just comes down to who do you want to solve for first. And it doesn't matter. Well, we're going to do all 3 of them, actually. Let's start off and go for theta 1 first. So you say it's okay to have theta 1 in there. So we're going to go in the toolbox and say, gee, can I find, and we will be able to, but can I find an equation that has theta 1 as the only unknown? Or another way to say it is I want an equation that does not have 2 and 4. And we're going to get to the point that the reason I drew that picture there is when I draw that picture, to me, the equation is just jumping right off the page. So I'm going to go ahead and show it that way. I know it's going to be a cosine law. I don't know if it's a fundamental or a subsidiary. Right, a fundamental was like Z432 equals, what, C51. It's going to be a cosine law because they have 1 less theta. So I know it's going to be a Z. And I'm going to just start writing. I'm going to show how I do it from the picture, and then we're going to look and make sure it's in the appendix. And it will be. But I'll say, it's okay to have 5. Right? Okay, I need 3 thetas, though. So I know I'm not done yet. So I go, is it okay do I want to put a 4? No. Do I want to put a 1? Yeah, that's okay. It's okay to have 1. That's what I'm looking for. Now, if I was to put a 2, I would get a fundamental law, but I don't want theta 2. So I'm going to stop. And I'm going to say, wow, I only have 2 thetas, so I know it's not a fundamental law. It's going to be a subsidiary law, and all the subsidiary laws are z's. And then here's my, again, I took it was a freaking closed book. I was like, holy cow. I think we did have the appendix, though, but Z51, here's what I did. This is the way that I sort of remembered it. And I took my fingers here and I took a step. And I said, does 5,1 equal Z432? No, that'd be too many thetas. So I take another step. That is equal Z3. I'm going to put a bar, even though it doesn't matter, because if I'm doing 5,1, I'm going to go the other way. And I'm going to say, gee, let's see if that's in the appendix. Let's see if that's in the toolbox that we have. Z51 equals Z3 bar. So we go over there, and oh yeah, it's in there more than once. It's in there 4 times. All right, because Z51 and Z15's definition are identical, and Z3 and Z3 bars. So yeah, we've got some repetition in the toolbox, but that's okay. Now, I'm going to do it like that a bunch from the picture, as we go forward here, but there's nothing wrong with just looking through the toolbox and finding an equation that does not have 2 or 4 in it. Okay, so in this equation, theta 1 is the only unknown, so we're going to go ahead and expand it. So it's going to be sine xs plus yc plus a cosine z, and I'm going to say minus z3 bar equals 0. And let's see, 5,1, we're going uphill, so there's no bars on top of those. 5,1, the next number is 2. And when I look at this equation, I can now write it in the format of S12Y5 times C1 plus S12X5 times S1 plus C12Z5 minus Z3 bar. Then we're going to say, based on all the stuff we're given, all the alphas are given, theta 5 is given. So Y5's definition, right, has alphas and theta 5, so that's going to turn into a number. Again, that's everything in parentheses is going to evaluate to a number. And again, theta 5 is given, theta 3 was given. Everything in parentheses there is going to evaluate to a number. So basically, we've got A, B, and D, and we know how to solve that. All right, so if we started off where we were given theta 5 and theta 3, at this point, we would say I have a theta 1A and a theta 1B. So, but to me, the big key was once you do your problem statement, you decide who you want to go for first. This is the most important step. So, and we're going to go through this. We're going to be doing so many of these. I call it, I don't want to call it teaching by boredom, isn't the right way. We're going to do so many of these that once you get it, you say, I get it. I don't need to see any more of these. So it's almost like when everybody's forehead hits the table, then I know I'm done. So I declare victory at that point. But for the first time, you say, wow, you drew that picture and you circled what was okay to have in the equation, and the equation kind of jumped at us. So, yeah. And once we got that equation, it went into a format that we know how to solve. Okay, next thing we're going to do then is we have to get the corresponding values of theta 2 and theta 4. I expect to, for theta 1a, I expect to get the sine and cosine of theta 2. And for theta 1a, I expect to get the sine and cosine. So I'm going to need two equations. I always look at the buddy equations. I'll start off and say z51 equals z3 bar was so good. Let's look at x51 and y51. And I say we're going to have to go into the toolbox to take a look at what those are, but I know they're not fundamental sine and sine cosine laws because they only have two thetas in them. So when I looked at all the patterns, we would get an x and a negative x star. And 5,1, it's going to be 3,2. And let's double check that it's in there. And again, I didn't have to go to these buddy equations, but it's like, man, it seems to always work pretty good. So we found those two equations. So when I looked at those, I'm going to say, well, they've got theta 5. I can put theta 1a into here. Theta 3. Oh, let's expand these definitions. So I'm going to erase this part, and we'll put these equations over here. So I'm going to say x51, I'm going to put it over here. x32 is x3 bar c2 minus y3 bar s2. Negative x3, I'm going to put the minus sign over here. And I'll have xs plus yc. So I'm going to take those equations, and I'm going to take the given theta 3, and I'm going to get, I didn't really want to circle that one, but I'm going to get numbers for the x3 bar and y3 bar. Here's my unknowns. I'm going to take the alphas and theta 5, and I'm going to put theta 1a in there and get numbers for the a case. And then we're going to solve two equations, two unknowns. So for the a case, then I'm going to take those same two equations. Well, theta 3 didn't change, so those are evaluated. Theta 5 is the same, but I'm going to put in theta 1b and get new numbers for x51 and y51. And then I'm going to solve two equations, two unknowns for the b case. Knowing the sine and cosine for the b case, I know the unique theta 2b. Oh, okay. And miraculously, when we solve these two equations, two unknowns, if I take the S2 value that I get and square it, and the C2 and square, they're going to sum to 1 because the geometry will hold together for us. So, okay. So we got one angle left, and the last angle is theta 4. And again, we're going to go into the toolbox and find two equations so we can get for the A case and the B case the sine and cosine of theta 4. And what I do is, there's a lot of different equations we could pull out of the toolbox, but I look at z51 equals z3 bar, and I looked at those buddy equations, x51 and y51. And I said to myself, of course, this is going way back in time because it was kind of closed book. Let's look at x. I know that z51 is the same as z15 by definition. So let's look at, just to start off with, let's look at these equations and see what we get. So I know they're not fundamentals because they only have two thetas and a pentagon needs three thetas. So they're not fundamentals. I'm going to get an x and a negative x star. In 1, 5, it's going to work out to be 3, 4. And let's double check if that's in the toolbox. Yeah, they're in there. So we look at those equations and say, well, theta 5 is given, and I do have an A case for theta 1, and theta 3 is given, and oh yeah, we're going to expand that x3, 4 minus y3s4 equals x15. I'm going to move the minus sign over here, negative y15, and I'll have an xs plus a yc. There's my unknowns. I take the given theta 3 and x3, y3, evaluate to numbers. Over here, theta 5 is given, but I'm going to take theta 1a and evaluate that as a number and evaluate that as a number for the A case. Boom. Same two equations, but now I'm going to take theta 1b and evaluate the x15 and y15, and boom. And we're done. So to me, this toolbox approach really pays off, right? It was a pain in the neck, the notation, oh my goodness. I was at a conference, it was in the 80s, and I heard somebody in the audience, Dr. Duffy, if he was presenting or one of the students, and somebody says, oh, no, it's that XYZ stuff again. And I'm well, yeah, it pays off to have this notation. Otherwise, the equations get unmanageable. You can't tell what's going on. It's about the, right, you can't see the forest because of the trees, kind of a problem. But with the notation, we can keep the big picture. And I don't have to start from scratch every time. I don't have to regenerate this equation from scratch. My toolbox is all ready to go. So we've got some pretty powerful stuff to solve these problems. Okay, 850. So in general, nobody's making like really like faces like that, right? Like they're, what's going on? Now, again, I'm not numerically doing it, right? We save that for you for the homework. Because again, you have to take the A case and evaluate x15 and the B case and da-da-da-da-da. Oh, hey, what's one way you could check your result? Suppose I get all these angles and I want to check the results. Okay, at this point, for the A case and the B case, I know all the alphas, I know all the thetas. So if we wanted to check it, you could come up with this matrix, right? What's the for the spherical mechanisms, we only need the rotation part, right? Because the origins haven't moved, they're all the same. And then you could evaluate this matrix, and this matrix, and this matrix, and that matrix. And if we multiply them all together, you're going to get what's the rotation matrix of 1 relative to 1, which should be the identity matrix. So I should have thrown that out even back when we did the 4-bar. But that's kind of a quick way to check. Again, for the A case, you take all your A case angles and evaluate those rotation matrices and multiply them out. Better get the identity matrix, and then you put in your B case angles. Okay. So we're going to do this problem 3 times. Okay, I'll keep that, get rid of that. And this time what we're going to do is say somebody wanted to go for theta 2 first. And you're going to get the same A case, B case solutions, but our toolbox has got so much stuff in it that, yeah, it's no problem. We can go for any of those first. So I know it's going to be a cosine law, so I start off with a z, and I'm going to put a 5, because I know it's okay to have theta 5. And then I go, gee, oh, we're trying to find theta 2, right? We're trying to find that one. So do I want to keep going? Do I want to put a 1? No, I don't want theta 1 in the equation. Do I want to go the other way and put a 4? No, I don't want theta 4, so I'm going to stop. So I know it's definitely not a fundamental law because right, they have 3 thetas, and I only got 1. So I put my fingers here, and I take a step, and does it equal z? 4, 3, 2, 1, that's too many thetas. So I take another step, and as I drop the chalk, I'm going to look in the toolbox and see if that one exists. And it darn well better. It existed last year. I'm trying to hit the erase button, and I can't find my mouse. There we go. So we're looking for Z32 equals Z5. It's going to be a subsidiary. And again, it appears 4 times because of the, because of Z5 equals Z5 bar and Z32 equals Z23 by definition. Yeah, so there's an equation that has theta 2 is the only unknown. So we're going to expand the Z32. It's going to be a sine x3 bar xs plus yc. It's going to be a 1, 2 plus a cosine z. I'm going to say minus z5 equals 0. And again, we factor this into the format of S12 Y3 bar, S12 X3 bar, C12 Z3 bar minus Z5. Theta 3 is given, so that's going to evaluate to a number. Theta 3 is given. Theta 3 is given, theta 5 is given. Oh yeah, that's why we got that function. That's why we're having you write that function, is because it's going to be usable to us so many times or so often. So from this result, given A, B, and D, I know that there's two possible answers for theta 2. And you say, okay. So now we've got to get the corresponding values for theta 1 and 4. Mm-hmm. Any question? Say again? Did I forget an S2 term? Oh, thank you. I sure did. I was so happy to get the parentheses done, right? Because it's got to be that times S2, but that's, yep, into the format that we had. So now it's a matter of getting the other, and again, I expect for theta 2a, I expect to get the sine and cosine of theta 1. For theta 2a, I expect to get the sine and cosine of theta 4. So I'm going to need two equations. And boy, the toolbox has got so much stuff in it. Where do I even start? Well, I don't know. That one did so good for us. I'm going to go for, I don't know, x32. Write it over here. And y32, just to see what happens. So again, I know they're not fundamental laws because they only have two thetas. And when I looked at the appendix, I was getting stuff like that. And then 3,2 is going to be 5,1. And we're going to look in the appendix and see if that's in there. Now, are those the only equations to pick that solve? No, there's a whole ton of ways you can do it, but boy, this approach seems to work all the time. So I'm going to look through here, and I'm looking for x51, or sorry, x32. Yeah, they're in there. So what was good about those equations? Theta 3 is given. I've got an A case for theta 2. Theta 5 is given. Hey, theta 1's my unknown. So we're going to expand x51. And I'm going to put this negative sign over here. And holy cow, here's my unknowns. Like they're two linear equations in these sines and cosines of the unknown theta 1. And again, based on what we're given, all the alphas in theta 5, x5 and y5 are going to just evaluate to some numbers. x32, theta 3, right, has theta 3, theta 2, and a bunch of alphas. Theta 3 is given. I'm going to take theta 2a, plug them in there, and get numbers for those values, solve two equations, two unknowns, and we have theta 1 for the A case. I'm going to take those same two equations, except this time I'm going to put theta 2b into those expressions to evaluate them. Solve two equations, two unknowns, and we got that. And again, why did I pick those equations? It's because I just came up with something that seems to work every time. In other words, this equation got us going so good. Let's try, I call them as buddy equations. And then, well, let's try these buddy equations. That's supposed to be a star. 2, 3 is going to be 5, 4. And let's double check if that's in the appendix. Yep. So again, I was looking for equations where theta 4 is going to be the only unknown. There's a ton of them. These seem to work pretty good all the time, so I'm going to go that way until it stops working. It's never stopped working. Okay, we're going to expand x54. My writing's getting worse. Let's see, let's move the minus sign over there. XS plus YC. We got two linear equations and two unknowns. Theta 5 is given, number. Theta 3 is given, but I'm going to take theta 2a, evaluate those for the A case, solve two equations, two unknowns. We got theta 4a, and then I'm going to use those same two equations, but now we're going to put theta 2b in there, the B case. Oh, okay. So to get started, when we went for theta 2 first, we found the equation. But when you go for the corresponding ones, there's a lot of ways you could go because there's so many equations that could give you the sines and cosines of those unknowns. But the buddy thing just seems to work pretty well. So I've just been sticking with it for like 30 years. Okay, so has anybody's head hit the table yet? We're up to 9 o'clock. We're going to do this problem one more time. Do this problem one more time, except this time the person that's solving it decided to go for theta 4 first. So how would they go into the toolbox and work this out? It's okay to have 4. So you'd say also another way to say it is I want an equation that does not have theta 1 or theta 2. I'd like theta 4 to be the only unknown. So I know it's a cosine law. I go with the 5 because 5 is given. Do I want to write 1? No. I don't want theta 1. I go the other way. Can I put 4? Yeah, it's okay. Can I keep going? Yeah, it's okay to have 3. Yeah, I got fundamental equation. Let's double check if that's in the, in the appendix. So if you go for theta 4 first, it sure looks like we can go with the fundamental equation. So we go up top and we find Z543 equals C12. Okay, so we're going to have a little bit more work though on this one because the unknown in here is theta 4. We're going to have to expand this twice. So I'll do it on the board over here. Z543 is sine xs plus yc plus a cosine z, and then I'm going to say minus c12 equals 0. So that'll complete that equation. 543, 543, 543, 54, 543, so it's going to be 2, 3. Then I have to say where x54 is x5 bar C4. Oh my goodness, and y54 is cosine xs plus yc minus a sine z, and z54 So we expanded all those definitions. We are going to have to jam these up in there because the unknowns are here, right? That. So I got to do a bit more work here. So Maple is really good at this, right, of substituting those in, because what I want to do is find everything that's times C4, and then everything that's times S4, and then everything else. So it doesn't look like it at first, but it's going to go into that format of A times cosine 4 plus B times sine 4 plus D equals 0. It's just, holy cow, what's got a C4 in it? Well, it looks like there's an S23, S3, X5 bar. Okay. Now, I'm trying to get C4, so if I come down and substitute there, I'm going to have an S23. Oh, no, I'm still going on C4. S23, C3. Looks like there's a minus sign. Looks like there's a Y5 bar. No, wait. I'm getting all messed up here. I'm going for this term. S23, C3, put the plus sign back, and then it's going to be C34, Y5 bar. That took care of that term. And then for this one, it looks like we have a plus C23, S34, Y5 bar. So that looks like what A is going to evaluate to if I did it right. I'm not looking at it too good right now. So I took these definitions, right, substituted them in here, and I'm trying to group all the cosine 4s together. And if I did it right, I'm in the ballpark anyway. Something looks a little fishy here, though. Like, did I leave a term off? No, I guess we're okay. And then if we group the S4, you're going to get something similar. I'm not going to push my luck because I'm sure I'm going to mess that up. And then the Z4 is going to be everything that's left over. So there's going to be a term here and a term here and all that other junk. But it will go into that format, A cosine plus B sine plus D equals 0. But going for theta 4 first, right, is a little bit more work. A little bit more work. But when we go for the corresponding angles, we're going to find that it's going to be less work. It's going to go pretty simple. So we did have to, expand the definitions twice, substitute in, and regroup it correctly, but it will go into a format that we know how to solve. Okay, for the other angles, I look at my buddy equations. Let's look at this one. Hey, they're fundamentals. Five, 4, 3. We're going to check that that is in the book or in the appendix. So I went to these buddy equations. X and Y, yep. So why is that nice? Well, I'm trying to get this, looks like they're going to get us the sine and cosine of theta 2, and they're staring right at us. I don't have to solve two equations, two unknowns this time. So I had to do a little bit more work to get the theta 4 first, as far as regrouping and all, but boy, this is nice because I'll take the given 5 and the given 3, and I'll take theta 4a. Number for the A case, From these same two equations, I'll take the given theta 5 and 3, but I'll take theta 4 the B case, get new numbers over here. So yeah, I didn't even have to solve two equations, two unknowns. That was pretty good. So there's one angle left, is theta 1, and we're going to go for, let's try the other buddies here. X3, 4, 5. Just see what happens. You got nothing to lose here. They're fundamentals. And that's what I'm hoping to find is sine 1, 2, sine 1. What are we looking at? 3, 4, 5. Oh, yeah. Beautiful. Because again, the sine and cosine of theta 1, they're staring right at us. So I'm going to take the given theta 3 and 5. I'm going to take theta 4a. Evaluate numbers for the A case. Boom. Same two equations, but this time when I evaluate these, I'm going to put theta 1b in there, get new sine and cosine for the B case, and we are just cooking. So it was a little bit of a hassle when we went for theta 4 first, to get that first equation factored the right way, but boy, when I use Maple, it never makes a mistake. Or if I just take my time, right, we could do that one. But when we went for the corresponding, these other buddy equations, boy, they went pretty simple what's out there. So hopefully you're getting the hang of it. We've done this one 3 times. We're going to go ahead and let's do a similar but different problem here. I'm going to stay in the Pentagon, and we're just going to change up, what we're given and things and what we're looking for. So suppose I gave, I don't know, let's say theta 2 and theta 4. So we have to find who's left, 5, 1, 3. And every year I always say I want to get you all 8.5 by 11 piece of paper and a marker. And we'll set this up, and let's say I'm going to go for theta 5 first. And then I just want everybody to write down what's the equation you're going to start with. And you hold it up, and I've never done it, right? And hopefully everybody'd have the same stuff, because that way we can go do something else, because that means everybody got it. Because this is the most important step of the whole thing, is once I decide who to go for first is, boy, I got to find an equation that has that as the only unknown. So I'm going to mark this as it's okay to have 5. That's what I'm looking for. I know it's going to be a cosine law. It's okay to have 5. It's okay to have, I don't want to put a 1 because I don't want 1 in there. It's okay to put a 4 though. Do I want to put a 3? No, I don't want. So I'm going to stop and say, well, I've only got 2 indices or 2 thetas, so I know it's not a fundamental law. All the subsidiaries look like that, and I go 5, 4, and I take a step. Oh, that's too many thetas. The 3, 1, 2 would be too many, or 1, 2, 3, and I take another step. Say, boy, I hope that's in the appendix, and it will be, because that's an equation that has theta 5 as the only unknown. So we're going to erase that, and we're going to look for Z5, 4. It's in there 4 times. Yep. Yeah, it was in there. So when I talk about it, the equation just jumped off the page at me. It's because I drew this picture, and I circled what I knew, and I marked this as it's okay. And I said, well, yeah, that's got to be that equation. Now, when I expand this, because theta 5 is the unknown, I'm actually going to expand this one, 4, 5, right? Because the theta 5 will pop right out. It'll be a little bit, you get the same answer, but it's going to pop right out. So Z45's definition is XS plus YC 4, 5, what's that, 5, 1? Plus cosine 5, 1, Z4, I'm going to say minus Z2 equals 0. We have S5, 1, Y4 plus S5, 1, X4 plus C5, 1, Z4. I don't know why I'm trying to write so fast, because I know where I want to stop today, so we got plenty of time. That was the most critical thing, though, was looking at that picture. If I want to go for theta 5 first, yep. Or you just go through the toolbox, and find, where theta 5 is the only unknown. And by golly, stuff in parentheses based on what we're given. Theta 4 is given, all the alphas are given. That's going to be a number, a number. Theta 4 and theta 2 was given. So and then again, you're writing a function to solve that kind of equation. So our solution tree said we started off with theta 2 and theta 4, and we know we have a theta 5a and a theta 5b. Yeah. Which is supposed to be S5. Down here? Oh, thank you. Yeah, I'm being really bad today. I'm writing this stuff on the board, but I'm actually thinking about something else. So I'm not even paying attention to what I'm supposed to be doing, but thank you. Okay. So we're in pretty good shape. I mean, so again, oh no, this notation, X, Y, Z, this giant toolbox. But holy cow, when we get a problem like this, it's pretty handy to not have to generate those equations from nothing again, start taking S5 in the fifth and trying to, oh my goodness. So we're in pretty good shape. Okay, so there's 2 angles left to go. Digging around the toolbox, but why don't I look at the buddy equations, like x45 and y45. They're not fundamentals. 4, 5. So the way I've been pulling these out of my head is I go 4, 5. Let's see, 4, 5 was 2 coming downhill, like 2 bar. So when I go to x and y, it's going to be 2, 1. So I just realized I had to get one more term there, but it's really not that big of a deal because you can always look in the appendix to verify. So we're looking at x45. Yep. But way back yonder, where I was lucky to just have a calculator, let alone MATLAB or something, but had to come up with a way to remember these. So how are these equations going to help us? They're going to get us theta 1. We are going to expand. We are going to expand x21. And I'm going to put the minus sign over there, and then x21 star. xs plus yc. And again, we've got 2 linear equations and 2 unknowns. Theta 2 was given, so x2 bar, y2 bar are just numbers. Let's see, over here, theta 4 was given, but I'm going to take theta 5a and plug in and turn those into numbers. So I got 2 linear equations, 2 unknowns, boom. Same 2 equations, it's just this time when I evaluate the x45 and y45, I'm going to put theta 5b, get new numbers over there, solve these equations, knowing the sine and cosine. Boom. And again, why did I pick those 2 equations? Because I got into the habit and they seemed to always work. It didn't have to be those 2 equations. When I wrote them down, I wasn't sure what I was going to get over here and was it even going to work, but it's always worked. Okay, so we got one angle left is theta 3. Again, 4, 5 did so good. Let's look at the other buddy equations, 5, 4. So you say 5, 4, they're not fundamentals. It's going to be 2, 3, and we're going to verify that. The 5, 4 equation. Oh, they're way down here on the bottom. Yep, so they were in there. So how are we going to use those? Well, they're going to allow us to get the theta 3 term. We're going to take those 2 equations and say x23 I'm going to put the minus sign over there. xs plus yc up. Wait, 2, 3, 2, 3. Here we go. There's our unknowns, sines and cosines of theta 3. Wow, x2 given. Theta 4 was given, but I'm going to jam theta 5a into those. For the a case, I got 2 equations, 2 unknowns. Then I'm going to take those same 2 equations and jam theta 5b into there. And again, there's other equations we could have used to get the sine and cosine of theta 3. Now in the book, I don't give it as a homework anymore, but there was a question that said, given 2 linear equations and 2 unknowns, solve it. But now, MATLAB's got that pretty much built in and stuff, because we're going to need that quite a bit. So I didn't give that as a homework. But when people were programming just in C or C++, then yeah, they would write a function that would do that because they're going to need it. so we're doing pretty good on this. Okay. We only got a minute left, so let's just do one quick thing here, because the next class we're going to go to the six-sided. Suppose I went for theta 1 first. Does the equation jump off the page? I don't know if I put a bar or not, doesn't matter. But yeah, because it was okay to have 2, it's okay to have 1, that's what I'm looking for. Oh, I had to stop. 4. So again, when we expand this, you're going to get a cosine 1 plus b sine 1 plus d equals 0. If you went for theta 3 first, oh, it's a fundamental. Oh, so we're trying to get theta 3, so it's that issue we had before where you had to expand it twice. But you would get it into that format of a cosine 3 plus b sine 3 plus d equals 0. So, yeah. So hopefully the toolbox stuff is paying off. It's a pain in the neck, and it was a lot of work. Like, I can't believe when we took all those z vectors and went back to the first, oh my goodness, and all this notation was popping up, and it seemed like it was never going to end. And we do have all those polar equations, although we haven't had to use them at all yet. So there's a lot of stuff out there. But you okay? Like you said, we're going to do 6 and 7-sided, and then tell everybody. Now, the bad news, though, is I think at the end of chapter 6 is when we have our next test. So we have to start figuring out when that's going to be and what's it all about, that kind of a thing. But, okay, so we will see you on Wednesday. Hooray. No hurricane week.